a trinomial. Factor is binomial or trinomial completely. So first of all, in the A, we have a 4m squared minus 19, 9 over 16. So let me take one pen here. And 4m squared. So 4m squared is a squared here, and the second term is b squared, which is 9 over 16. Because 9 is a square number, 16 is a square number, and this number I can write like a 3 over 4, because 3 squared is 9 and 4 squared is 16. And because here is I have a plus b, it means 1 I can make a plus here. And a is a 4m squared. This is a square number because 2 in a square is a 4 and m in square is m squared. So it's a 2m. But because here I want here a little bit to write in this space, and in this space I will write a minus b. I could write here, but I want to leave some space for the b problem, so let me write here in the beginning. And this one I can write, instead of a, we already said is a 2m, and instead of the b is a minus sign, one has to be minus and the other plus, 3 over 4. Because the commutative property in multiplication works, so I can change those binomials. I can put one binomial in the front, another here. Like for example, x times y is equal with y times x. So commutative property in multiplication works, therefore I have this right. And now in the b example here, I have a plus b squared, and this one I can write in this form. The first number is a squared is a, but 100 is a square number and y squared is a y. So this one I can write in this form. I can write 10y, and because it's a square of the sums, I can make this in this form plus imaginary number ib or bi. I can write in either way, but let me write the bi here, and let me write the bi instead of the ib. And here we have a 4 over 9. The 4 is a square number, which I can write 2 over 7 because 49 is a square number, and this I can write 2 over 7, and here everything is I. And the other part is the same thing like the first binomial, but the sign has to change. So I can write 10y minus 2 over 7i, minus 2 over 7i. And the last one, minus 2 over 7i, and the last problem is a c. Let me write it with a different color. And c is, if I have a squared minus 2ab plus b squared, I can write like a minus b squared. This is a trinomial, perfect trinomial squared. And this trinomial perfect square I can write in this form, a minus b squared. If it's a plus, a plus b squared, a plus b in a square, I can write as a perfect trinomial. If it's a positive, I can write a squared plus 2ab plus b squared. But because here is a negative sign, so therefore I'm going to use this formula here, a minus b squared, which is equal with a squared minus 2ab plus b squared. But first of all, I'm looking, the last number has to be square number, because b is a square number. But this is a square number, is 2 over 7, because 4 is square number, 49 is square number, and everything is 2 over 7. But in the beginning here, this term b, I have to verify here, 2 times b, 2 times this number here, and 2 times 2 over 7 has to satisfy this middle number here, the b. And it's satisfied because 2 times 2 is a 4 over 7, which is a 4 over 7. Doesn't matter if it's negative or positive, we have to satisfy it just in this way. So in this case, we have to write now. So a is a square, which is a in this case, but a here is a t square, is just t. And I'm looking, here is the negative sign, I write a negative sign. And is a b, but the b in this case is this number here, b. and this number is 2 times b. 2 times b. Always has to satisfy this number. And the last number, b squared, and b squared was 4 over 49. If we are taking a square root on both sides, those are a perfect number, is going to be 2 over 7. 2 over 7 is just b. 2 over 7 times 2 over 7 gives us 4 over 49. So now, here we have a 2 over 7, and everything goes in the square. So that's how we can convert those trinomial perfect squares in a binomial square.